All right, so this is your how-to for doing worksheet number 6 when we're converting percent compounds to empirical formulas. So I'm going to write the little poem down in the space for number 2 here, just because it really does help us guide to what we need to do. The first thing we need to do is think about it as percent to mass, and then mass to moles. We're going to divide by part, or small, and then multiply by whole. So let's see how this works. The first thing is I'm going to take my percents and I'm going to say that they're the masses. So if I've got 83.7 and 16.3, we're going to pretend that the weight of the compound is 100 grams. So it would be, I would have 83.7 grams of carbon, and I would have 16.3 grams of hydrogen. So now I've done the percent to mass. Well, now I need to find out how many moles I have. So now I'm going to do the mass to moles. So times, if we have grams on the top, we're going to need grams on the bottom. So 1 mole of carbon, you can look it up on your periodic table, is 12.01 grams in 1 mole of carbon. For this one here, hydrogen is 1.01 grams per 1 mole. So the next thing I'm going to do is I'm going to solve that. So that's going to be 6.97 when I'm rounding to 3 significant figures. Notice how I'm putting that up high because I'm going to be dividing that by another number. For my hydrogen, I'm going to put that in my calculator, 16.3 divided by 1.01 equals, that's going to be 16.1. Now I'm going to look to see what is my smallest number of moles, because this is going to be moles. Because my units have canceled out. Well, 6.97 is smaller than 16.1, so I'm going to divide everything by 6.97. And that, of course, equals 1. 16.1 divided by 6.97 equals 2.31. So 2.31 and 1. But 2.3 is not exactly close to a whole number. So I'm going to need to multiply that by something to get it closer to a whole number. Well, if I multiply it by 2, it doesn't get me very close. But if I multiply it by 3, that equals 6.94. So that would be equal to 7. So if I multiplied this number by 3 to get it close to a whole number, I would need to multiply this by 3 also, which equals 3. So my correct answer would be C3H7 for my empirical formula. Let's try number 3. So it is, what's the empirical formula for a compound, as you can see. So I'm going to turn, the first thing I'm going to do is I'm going to turn my percents to mass. So I'm going to have 24.7 grams of calcium. I'm going to throw it over 1 just to make things even out a little bit. My next one is going to be 1.20 grams of hydrogen. Next one is 14 0.8 grams of carbon. And my last one's going to be 59.3%. Sorry, not percent. Let's change that. Grams of oxygen. Throw it over 1. So the next thing I'm going to do, percent to mass. I've completed that step. And now I need to do mass to moles. I've got grams on the top, so I'm going to need to have grams on the bottom. The weight of a mole of calcium is, looking on my periodic table, 40.08 in 1 mole of calcium. Got grams on the top here, so I'm going to need grams on the bottom. 1.01 grams in 1 mole of hydrogen. Grams are on the top, so I need grams on the bottom. A mole of carbon is 12.01. And oxygen, 16.00 grams of oxygen in 1 mole of oxygen. Now I'm ready to put this into my calculator and find out how many moles I've got. So 24.7 divided by 40.08 equals, and that's going to be 0.616, and that's going to be moles of calcium. So I'm going to pause this, figure out the other ones. Remember, I'm writing this up high because I'm going to be dividing it by the smallest number once I get them. So now I've gone ahead and divided these out. And now I'm going to look to see which one is the smallest. Well, here's 0.6 moles. Seems to be my smallest number. So I'm going to divide each of these by 0.616. And then I'll put it through my calculator and see what I have. We know that's going to be 1, of course. So these are the numbers I get when I divide it out. So we've got 1. This is very close, and we'll call that 2. This is very close, and we'll call that 2. And this is very close, so we'll call that 6. So we don't need to do any further multiplication to make our whole numbers. And so our empirical formula will be Ca1, which we wouldn't really need to write. Hydrogen, we're going to have 2. Carbon, we're going to have 2. And oxygen, we're going to have 6. So our final one will be Ca H2 C2O6 for our empirical formula. So now we're going to do number 5. I'm going to do the same thing. First thing I'm going to do is turn my percents to masses. So 67.6 grams of mercury. And I've got 10.8 grams of sulfur. I'm going to throw these over 1. I've got 21.6 grams of oxygen. So my percent to mass is done. Now I need mass to moles. So I need to find out how many moles I've got. Grams on the top, grams on the bottom. Go to the periodic table, and I'm looking for mercury. And mercury is 206, or 200.60 in 1 mole. My next one is sulfur. Sulfur, I look on the periodic table, and it's 32.06 in 1 mole of sulfur. Oxygen, I pretty much got that one memorized by now, as well as you probably do too. 16 grams in 1 mole of oxygen. So now I'm ready to do the math. I'll put it on pause here and go ahead and calculate that. All right, so these are the answers I get, and now I'm going to go ahead and divide them by the lowest number. These two are the same, so 0.337, which of course is going to equal 1, divided by 0.337, which of course is going to equal 1, and divide this by 0.337, which equals 4.01, which is equal to 4. So my empirical formula for this compound is going to be Hg, and I'm going to have only one of them. Sulfur, I'm going to have 1. And oxygen, I'm going to have 4. HgSO4. Here's the answers to the even-numbered problems. Number 2, the answer is CCl4. Number 4, the answer is Zn3 P2O8. And number 6 is OH.